fiasco is now being recorded. All right, so here we are, week 4, topic 4, halfway through. We made it this far. I'm going to get tougher on my grading though, so hope you don't let up on your performances. So I'm going to become a stickler. Well, yeah, we'll see. All right, so our next topic is advanced SQL features, sort of, and we're going to talk about aggregate functions. A very, very good topic. It's very, very useful in SQL and other facets of analysis. And it makes it easier to understand the data. All right, so our schedule, I asked you if you had questions. No one spoke up, so yeah, it's too late. You can't speak. I'm going to showcase Ram's work from last week. Basically, I'm going to have him walk through his solutions. And essentially, if I showcase your work, as I said, you get participation points for the next week. So you're exempt from the participation exercises if you want to be. But I would recommend, I mean, he probably will do them anyway, just go through the exercises because they help you to learn the material. And then the topic 4 objectives and a brief lecture on aggregate functions, and then a review of the assignments and DQs. And we will have in class, even though it's not on my schedule, we have some in class assignments to do or activities to do. And those are posted on the QTI, the question to instructor. So if you want to download those right away, so no cheating. But. All right. So Ram's going, I'm going to bring up his work, his submission, and he's going to walk you through basically, you know, how he walked through this assignment. So,
yeah, sure, Professor.
Or Ram, if you would like to take the screen, I would allow you to do that as well. So I don't.
Yeah, I'll take screen my control, so it will be easy.
So there you go. So I just want you to walk through your topic 3 assignment and just talk about your solutions. I thought he went well beyond. So the floor is yours, or the stage, or the Zoom meeting, or whatever. So I'll be quiet.
Yeah. So are you able to see my screen, all of you?
Yes.
Okay. So the first problem, I have actually both the PCs, Windows as well as Mac. So since this is more of like exporting and import features, so what I have done is I have used my Windows PC. So using that, what I have done is I just exported. So this will show up, successful screen prints of the completion. And I created 3 tables. One is month 1 donations, month 2 donations, and month 3 donations. And this will show up like the data is, captured correctly in the tables. And then just for the, checkup side, I just executed the query. On the left side, you can see the corresponding tables and the field attributes. On the right side, I just wanted to know what is the count belongs to these 3 tables. I just taken a screen print, capture that information. This is just only about the exporting the data. I know there is an alternate assignment even for manually creating a table and inserting the information as well, but pretty much same for everybody till this step. Then this is a place where just like a union query on the all 3 tables. So it has only 2 fields. So the first statement is about connecting to the adventure walk, and then second, I'm just checking if the table in this assignment we wanted to create a temporary table, and using the table we need to show the information. So just preconditioning kind of a stuff. Just wanted to make sure that if the table is existing, I know I'm going to create a new table, but just for if you wanted to execute the same query multiple times, you will have unnecessary problems. So I just created this label. If it is existing, then delete it. Otherwise, I'm going to extracting. So this is the only one syntax. This automatically take care about the creating the table into command on the first query. that automatically creates the table, and the data also will be inserted in these tables, whatever the 3 joins we are executing. So one join, first one is on the month 1 donation, second one is a month 2, third one is month 3. Since it is a union all, we do expect a duplicate information as well here. And then once I created this information, then I just wanted to see the results. So simple select star from this temporary table. Just want to ensure that we have the enough information. So there are total 355 records for this particular query. Any questions from anybody? Okay.
Good job.
Okay, thank you. Then the second one is about the same way, but we wanted to know the summarized information. So what we would need is basically in each table, what is the summarized donation amount on the individual tables, almost like similar format till everything here. Instead of individual variables, what I have done is just included the aggregate sum function, which summarize the information on the donation field, whatever the amount is there. And then I'm just mentioned that one is a donation amount. The tricky thing here in the union all, what I noticed here, even though like you mentioned, as donation and month in the second and third query as a specific field, it doesn't matter. Whatever you put it on the first, select statement as the name, the same thing only it's going to reflect in the output. And then the main question for this particular problem is we need to know the summarized amount. So using this temporary table, we wanted to get the summarized amount. So using these 3 fields, the automatically summarized amount will be reflected here. So from the screen points, I just executed both, all of them together. So one is about the individual table, summarized amount, and the last one is about the overall summarized level information. 1 and 2, I feel like pretty much simple. Second one, we're just using the aggregate function for the sum field. And then the the next one is about problem 3. This took some time for me because as per our manager, he has mentioned that there is a duplicate entry, there is a mistake was happened from one of the employee. Then what I did is I just executed, this is in a query. This will tell us basically if we have any duplicate, that will tell if it has any more than one occurrence or not. It is a simple query. So what I'm doing is I'm extracting the employee ID donation and the count. So basically using this count, we will come to know whether it is a more than one occurrence or 2 occurrence. So for that, what I'm doing is based on my employee ID and a donation, I'm performing a group by, so it will give a breakup ID. Then I'm inside the group by, I'm using a having a function. Basically, this will create a condition on the group by class. So in that case, I'm just simply checking any count which is more than 1, meaning it's a duplicate. So I need to list out the duplicate entries from that individual table. Okay, so that is what the query. So what I have done is I executed this query for all the 3 tables, table 1, table 2, and table 3. When I execute it, if you see on the third table, for employee ID 199, for the donation amount 100, there is occurrence of 2. I know I even I looked into the other alternate assignment as well. In the alternate assignment, month 2, for the one of the employee ID 4, the $100 is repeated. If we can execute the same query, we will get the similar result. So from this particular, these 3 SQL queries, I just wanted to figure out what is the duplicate entry. Then I can conclude my analysis based on that. So by executing this information, I came to know that on table 3, as per the manager suggested, there is a duplicate entry for the $100. So his assumption is correct. So then as per the exercise problem, he is informing us to, instead of using a union all, execute it union. Okay. So if you see with the union all function, earlier we executed the same query because we wanted to replicate this one for the problem 1 query. So I just quickly go through this. Problem 1, we see when we execute this query, there are 354 records are there. This is a union all, so it will not remove any duplicate records from our queries. So then the same thing, instead of union all, I just change it to just union. So our assumption is that it's going to remove all the duplicates. So in the problem 2 section, I just simply did the union and then I executed. When I execute it, I see there are 323 records. But as per our analysis, we see only 1 duplicate record. But if you see from 354 to 323, it's not one record. There is a big difference here. So definitely union function, it's not just like removing a duplicate entry, it is doing something else as well. So for identifying, I have seen the query, then the situation has happened because union is basically removing all the duplicate entries. Okay, so if you see this query, what is happening is this is my first query, and then using my first query, I'm performing a union on second query. So out of these two tables, if any duplicate entry is, it is removing that information. Then that result information, again, that is performing on this third union. So in that result versus this third union, if there is any duplicate entries are there, then it is removing. But our solution is not this. Our solution is basically in a single table, there could be a multiple. If there are any duplicate entries, only we need to remove that information. For month 1, month 2, and month 3, same person, he can be doing the similar kind of a donation on every month. Actually, that is not a duplicate entry, right? What I'm saying here. If I'm going too fast, you can interrupt me, anybody. What I'm saying here is month 1, month 2, month 3, if the same employee, he put a donation on the same amount, then it will be considered as a duplicate. It will be deleted from the our overall execution. In ideal scenario, this shouldn't be the case. Only on that month itself, if somebody repeated the same amount twice, then only that information is to be removed from our list. So what I did is simple thing for for this solution. Same union all included, but I included a distance function. So I'm performing a duplicate on individual table, not on the overall. So this function, what it does is it will see any duplicate with that employee ID in the table, it's going to filter out. Then that result will be performed on this union. So we will not have individual table entries will be picked up for that. So that way, if I execute this query, you see the total entries are 353. So first one is 354. Then as per the manager recommendation, we concluded, yes, there is a duplicate entry of one record. Then instead of union all, I made it as a union, but the record count came to be a 323, which seems to me wrong because I know only one entry is a duplicate. Then by looking into this query, then I understood, yeah, this is what the issue. Then to circumvent this issue, simply I just used a distinction function on the employee ID. So that will remove all the duplicates. Any questions from anybody?
I do have a question.
Yeah, sure.
So you use union. So as I think you're saying, so when you use union, you got the same answer, right?
Union, I got 323 records. With the union all, I got, you see, right? 323 at the down here. With the union all, it will not remove the duplicates. It has 354. But if I just change that union all to union on these three tables, I got 323 records. But from my analysis, I know there is only one record is duplicated twice. So ideal scenario, that 354 should be 353. It shouldn't be 323, right?
Oh yeah, you're right.
Yeah. So for my output, I'm expecting 353, not 323. To overcome the situation, what I did is I put a distant on the individual function so that it will remove in a table. If you have a multiple occurrence of the same employee, then it's going to filter out. In that way, then I'm performing a union. So from this table to this table, internal table, if you have anything duplicate, remove it. But month 1 and month 2, I told you the explanation. The same employee can submit the same amount of donation on every month. That is okay. That is not wrong. But if the same employee submits the same donation on a same month multiple times, then there is something wrong. So to circumvent that, I use this function, distant.
So does everyone understand that the difference in defining the union all scenario and then solving the issue for problem 3? Because a lot of you just did the union for all 3 tables, and yes, you came up with the 323, but you did not offer an explanation as to why. That should be a part of your analysis. Essentially, you should determine, well, you should come to the conclusion that yes, an employee can donate every month. So obviously there's going to be some duplicates across all 3 months. But you should have determined through your analysis on problem 3 that there's truly only one duplicate within the 1 month. So this, Ram just provided 2 ways for you to actually, come to that actual conclusion. So I hope that makes sense to you, because I'm going to expect, this level of analysis when you have those problems that involve assumptions, because you're going to prove or disprove the assumption is correct. And that's what I would like to see in your explanation.
Professor, I have a question here.
Go ahead.
What I did was, along with employee ID donation, I also added month in it. I mean, just in the single quotes.
Mhm.
So with that, even with union, it gave me 353 records.
Yes,
Is it because of the combination of all 3?
yes. You're still separating the months. See, that's the key. You're separating each month, and then you're evaluating the data from each month, as opposed to just combining all three and looking at the result. See, that's where you got 353. You're doing essentially the same thing that Ron did. So,
Okay, thank you.
yeah.
Okay, the last question is simple. Okay, this is a subquery. So he was asking about the national ID identifier number 4868, this one. So for that, what would be the last time period was changed? So for doing this problem, basically, I looked into these 2 tables. Okay, I know national ID number, it's always unique, but from the current table design, it's not a primary key. So I understood in an ideal situation, national ID number is a unique field. Everybody will have only one ID. But from our current table design, this is not a primary key. It means that there could be a chance that any employee also will have the same number. With that assumption, what I have done is, so this particular subquery, it will give the corresponding employees if anybody is there. I know in our particular problem we have only one employee, so it will solve very easily. But if anybody like put the same employee with the same national ID number, that also it will give this problem will give the information about that based on the business entity ID. That's the employee ID. So this query is basically, it will give all the business identity, the employee ID information for all the national ID, this particular number, and that information is being passed here. Then here what we are asking is the last time, okay, a pay rate was changed. So the simple thing what I feel is, if you use the max function out of those 3, okay, if any have multiple information, the max, it always have the latest information. So that way it will give you the answer. This will just simply, okay, let me showcase this result. So employee 13, for this employee 13, we have the last pay rate changed on this date. This is the result for that.
All right. Thank you. That was excellent work. I appreciate it.
Thank you.
Any questions? All right. Let's move ahead then. Okay, so thank you, Ram. I appreciate it. Okay, so let's take a look at our objectives for topic 4. Basically, we're going to spend a lot of time dealing with aggregate functions and dealing with nulls. So wrap your head around that. So our objectives describe aggregate functions in SQL and their uses. I'm going to go over a few. And remember, aggregate functions are like sum, average, date, etc. And then explain the uses of deterministic and non-deterministic functions. How many of you have heard of these terms used in SQL? Deterministic and non-deterministic. Anyone? Anyone? Well, I'm going to explain it to you briefly. You do have a DQ where you're going to express or provide an explanation about determinism and non-determinism. All right, so then articulate the process of aggregating nulls. As far as data analysis and data reporting and feedback reporting, yes, nulls cannot be a part of your analysis. They have to be dealt with. And essentially, in SQL, there's several ways to ensure that you're not eliminating the nulls because they are a part of how you would analyze the data, but you can't use them to do things like comparison, et cetera, and I'll talk about that more. And then demonstrate process of converting non-numerical data. And generally, there's several functions that can do this, but I'm not going to spend a lot of time on conversions. And we don't do a lot in analysis that much anymore because most databases are constructed so that the data types are clear and there's not any cross aggregation as far as data. So those are our objectives for topic 4. So what I'd like to speak to first is deterministic and non-deterministic. All right, so these terms are very specific. Well, they can be used for many things, but in SQL, and I want you to focus on how does this involve querying it, and when do you use it one over the other. So deterministic functions always return, and this is a very basic definition, and please do not complicate it. And if you think about it with the many different functions in there, and they're categorized in by these two types. So a deterministic function will always return the same result anytime that they're called with a specific set of input values, given the same state of the database. Now, you have to read that comprehensively because that is what makes it deterministic. I mean, it's the same set of values or variables as long as the database and the structure of the database is not fluctuating. Then a deterministic function will return the exact same value every time, all right? Now, a non-deterministic function, it is truly, and essentially, if you want to think of it this way, it's kind of the opposite, in some regard. Basically, a non-deterministic function will return a different result each time it's ran with the same values, and as long as the data, state of the access to the data remains the same. And you'll see here in a minute what is the biggest difference between the two types of functions as far as aggregate functions. All right, so a deterministic function would be average, the AVG function. Basically, if you're averaging over a set of variables, then or a set of return results, then if the data are not changing, then the average is always going to be the same. If you change one of the variables, then obviously the data is going to be different, or the result's going to be different, but the average function will always average, your variables or your literals. Whereas the getDate function, obviously the getDate is expanded to, well, we'll just say seconds right now. It actually goes further down the extrapolation, but the getDate function, whenever you run that, it gets the date down to the certain level of second. We'll just say second. So as time moves on, then the result will be different. So with that basic comparison, that's primarily the difference between a deterministic and a non-deterministic. Now there's certain usages, and I'm not going to go into detail, but you'll see that primarily at our level, the aggregate function and deciding which one to use, obviously, it's based on the scenario, based on if you're going to do any analysis or anything like that. But essentially, that definition will suffice for any type of aggregate function as far as their level of determinism. So in SQL Server, I just want to highlight the fact that over time, the developers and engineers at Microsoft have decided that, yes, we know that there's certain things that we have to maintain that it's deterministic, or there would be an instance where the data may be impacted by how a function is ran or a scenario put together. So essentially, there is certain parts of the database engine, specifically the SQL Server, and I'm just going to say that some of the aspects of it running in the backend will actually create a level of determinism based on what type of SQL you're running, and all that means is that it may seem like it's deterministic. Well, SQL Server will ensure that it is deterministic and the results will match what you're expecting. So the term determinism in SQL is just that. It's either a deterministic function or a non-deterministic function. Okay, so you cannot influence the determinism of any built-in function. So the built-in functions or the system functions, you cannot, well, from our level, you can't influence. Once you run that function and call that function, it is going to be a deterministic or a non-deterministic. And I just wanted to highlight the fact that, yes, you can probably change, well, the system functions you can't edit because no one has rights to edit those functions. Those come right out of Microsoft. So technically, you cannot change the determinism of these particular deterministic functions like average or count or sum. However, basically, if you use something like an order by is one of those built-in functions, but I mean, it may seem like it's non-deterministic, but it does a specific thing based on the criteria. If you say order by this particular column name, it is going to alpha order based on whether you have ascending or descending. And that you cannot change. So I just wanted to highlight that the determinism of order by cannot be changed no matter what type of query you're writing. All right, so if you want to get some idea of, well, to essentially evaluate a list, and there's thousands of functions. Well, okay, there's not that many anymore. There's hundreds of functions in SQL Server as far as deterministic functions. So this link is just one of the Microsoft links. If you go to the Microsoft site and search for deterministic functions, you'll access this list as well. So that's the link, and I'm pretty sure that link is in LoudCloud. If not, you can reference it, from the lecture when I upload it. Some of the functions that I want to just highlight briefly, a lot of these are math functions, and we're not going to do a lot of calculations and things like that, but for SQL, depending on the type of data, you can do several things. If you look at these, like the ACOST, ASIN, I know it's bringing back your trigonometry days, but yes, these are actual deterministic functions in SQL Server. Something like date diff. Date diff may fool you. Basically, it does the same thing based on the criteria. Whenever you see a date function, you think that that's associated with a specific date. Well, yes, it is. But this particular function is just returning a difference in two dates. Round, sine, sine and sine. Floor, I'll let you, explore that function. It does something interesting. Exponential, etc. Those are just some of the examples. There's a few more. Ceiling, so you can kind of get a sense of what floor is if you have a ceiling function. Is null, square, coalesce, cosine, logarithm, tangent, log of 10. All of these are true functions in SQL Server. Any questions about deterministic functions, built-in deterministic functions? I know I'm putting you all to sleep now, right? Right. Most of the configuration functions, and there's a ton of them in SQL Server, cursor, metadata, security, system statistical functions, they're all non-deterministic. They're all based on certain conditions, certain status, and even time frames. So for a list of these functions, once again, visit the Microsoft site. You can see some of the mostly used ones. like the configuration functions, just in case, like you probably won't get into a lot of the configuration functions for SQL Server, but if you're interested, they're all either in .NET or Visual. Yeah, I think they're all .NET now. So if you're interested in programming, you can look at some of those functions and dissect them, but they are all deterministic, or non-deterministic, excuse me. Cursor functions, metadata, security functions, etc. System statistical functions. These are all, if you're really curious about them, yes. And there's certain status functions that you need to pay attention to eventually. And even in this class, we're going to talk about users and rights and security a little bit for topic 8. So I just wanted to give you a list of those. And here are some of the built-in functions, the non-deterministic one. And I'll explain what the @s are. Those are actually functions. I know that you're probably used to the @ sign representing a variable. These can be considered, and I'll talk about this briefly, as global variables, but they essentially represent non-deterministic functions like CPU, busy, dbts, idle. These are all system-based functions. But you do have things like get date, get UTC date, get transmission status, lag, all of these things that look at the status of the server functionalities. And here's a few more: max connections, packets received, packets sent, packet errors. You may know anything about security and networking, total errors, total read. Once again, built-in system functions, lead, new ID, new sequential ID, etc. And you can actually use these functions in your select statements just like any other functions or part of your SQL statement. But you have to understand, well, it's obviously based on a scenario and what you're trying to accomplish, whatever scenario you're running. Remember, this is still SQL. It's not Java or Python. It's good old SQL. So I was thinking that you probably are worrying about the @ sign because you're used to declaring a variable, which is the SQL Server version with the @ sign. Some T-SQL systems function names begin with the double @, and these, as I said before, are sometimes called global variables, but they are not global variables. It's just kind of a verbiage, but they're simply built-in functions, and they're the non-deterministic functions. So just don't let those trip you up when you see the double @ sign. And I wanted to provide an example. The @max connections, if you wanted to run that, it returns the maximum number of simultaneous user connections allowed on an instance of SQL Server. And I think we're all running SQL Server 2019. Well, even if you're running 2017, I think if you run this select query, I think your maximum number would be like 36,000 or something like that. And on the Microsoft side, it does say the actual number depends upon the version. I can remember SQL Server 97, where the maximum number of simultaneous users was only 256. So, of course, that's many, many years ago, and things were quite a bit different. But if you wanted to run this, you can run this as a query in your SSMS. Just do a select, and then do the max connections, and then label the column, and it will give you. You probably will all return, and it's 32,767. And this is just showing you for your SQL Server version, there's the maximum number of simultaneous connections is that number. And it probably won't impact you at all because you don't have several users, you're not running simultaneous connections, but in a true SQL Server environment, there could be thousands of users hitting that database at any one time. So if you're having issues with performance, you do want to run that as even as an analyst, you can tell the DBA that maybe we need to change that configuration. But that's simply how you would run, because it is just a function, just like any other function. Any questions about that? All right. And here's a few more. These are all, and I do want you to investigate a few of these. It's not really homework, but if you go on the Microsoft side, you can read their descriptions and see how they can be used, like random number generator, etc. All right, our next big topic, that is basically our aggregate function topic. Let's take a deep breath. Our next big topic is dealing with nulls. And I do want to make a statement. I do not ever want to see a result table that you present as an assignment response with null. So every submission thus far for your assignment should not have a null in your result table. So I do want you, whether you're asked to or not, I want you to deal with nulls in your results. So I will remind you of that, but I do want you to understand that nulls are good for some things, but you never want to present a null on your report or even use them for analysis. So nulls in SQL are a mixed blessing. The three-value logic of SQL has its uses, but can cause difficulties to anyone who assumes that null has a value. All right, so who can provide me a basic definition of what a null is in SQL, in a SQL database? Or what is null? What does that represent?
No value.
No value. What does that mean? What does no value mean?
No
It
data
can-
was recorded. Oh, sorry.
Yeah, go ahead, no problem.
No data was recorded for that cell.
Thank you. That's a very, very good. Was that Jill?
Yeah, yes, that was me.
That's a very good representation. No value was recorded, which means you can't compare it, you can't view it literally. No value was recorded, or no value was even written, if you want to think of it that way. And if you read about, hopefully you all know who Sheldon is. Basically, he invented the relational database model and the ACID rules and all that fun stuff. But he talks about how there was a misconception about null, and database analysts and database administrators must know how to deal with and understand null. So null is a non-value, a non-existing value. It is not zero, and it's not an empty string. I had a lot of students really express some confusion about that. Null, they always think of null as being zero. Null is not zero. Null is nothing, or null is something, but you don't know what it is. Null is a non-value. A value cannot equal null. No two null values are equal. Remember that. I had another big discussion about, can't we compare null to null? No. So let me ask you, why can't you compare null to null?
Because we don't know what it is.
Yeah, you simply don't know what it is. So you can't, so you're just, what are you expecting? You're expecting it to be, still a null? Well, maybe it's not null. Anyway, null is a setting marker. Is a setting or marker that indicates if a data value does not exist. So the SQL Server Database Engine uses a special bitmap, and it really does to track nulls, which is why you have to be very careful that you're not using this as a value. So do not treat null. And I'm saying this a lot because I think you're all understanding, but it has to be understood because there's going to be some just problems that you have to face where you have to figure out how do you handle this particular situation involving a null. So let's look at this query. It's just a simple select query. Select title, first name, and we're using our actual table, middle name, last name from person, where title equal null and business entity ID is less than 7. So why would this query return an empty result? So why, if you ran this query, you would get no result. And you can try it if you don't believe me. But I think you all know why. What are we doing with the title?
You're comparing with null. That is,
Yeah, so we know that we can't do that. Even if there is null in the title, it's still not going to return that because it doesn't have a value, or it's expecting a value. All right, so that will return a result set. How about this one? And the double carets or the greater than, less than, whichever way you look at it, that stands for not equal to. Well, that's essentially saying the same thing. You're still comparing it, or you're not comparing it to a null value. So that will also return an empty set. So in place of that, the first query, you would want to run something that looks like this. Do our select statement and then use an is null. Is null is an operator function. Basically, it is the way that you would compare or just use a type of comparison. So the proper way to perform this is an is null or is not null. And these are essentially operators that you can actually add to your where clause. And this is the only way that you can actually use some type of comparison in a filtering scenario in your where clause. So please remember that is null is not null. So the next, I think the next few slides are going to be our exercises. Oh wait, using it. Oh, is this the assignment? Okay, DQ1. All right. I had my Zoom camera over what I was trying to reference. So discussion question 1 for topic 4. Using your experiences thus far regarding null values, and aggregation, discuss when it is a good idea to assume there might be a null data in your records. Explain why extra coding may be worthwhile. What I mean by extra coding is handling that null. What do you do to handle that null? Discuss whether one should only do the extra work involved in this process when there is an issue. Once again, this is kind of an analysis exercise. Justify your ideas with support from the topic materials and relevant industry examples. So I just want you to explain, basically, if you're looking at it and we have all types of records in there that have null values, how do you handle that? Are you going to need to do extra work to handle that null? And then is that necessary? DQ2, this is where we're going to talk about determinism. A determinism of a function is one of the several properties of user-defined functions, user-defined and built-in. I should include that as well. That determines the ability of SQL to index results. And that's just saying that, is it going to return the same, et cetera, et cetera. When and for what purposes would you choose to use deterministic versus non-deterministic to arrive at your desired results? And that's, once again, just critically think through this question. Don't overthink it. There's certain scenarios where you would use a deterministic over a non-deterministic. I just want a simple explanation of that with support from the course material or the industry or the web. All right. Okay, we have 2 facets of our assignment. Where the first one is aggregate functions. The second is null. All right, so on the first one, the purpose of this assignment is to examine the use of aggregate functions, analyze queries that contain null values, and use case logic, since you know what that is, to resolve the data and arrive at a solution. So you're going to have to analyze the data, determine where the case logic is needed, and then obviously I want you to understand and evaluate how to eliminate nulls from your solution. So for the assignment, you perform a set of exercises as usual. You can't wait for the problems, right? And you analyze data, develop corresponding aggregate functions, functions to obtain the required information. Okay, problem one, the sales manager asks you to provide the average pre-tax sales amount throughout the years. Now, what I mean throughout the years is all the years that are available in the AdventureWorks database. And you'll see that that's specific in that sales order header table. So using that table, what answer will you provide to the sales manager? So the average pre-tax sales amount. All right. Problem two, as part of an internal competition, the CEO requests that you provide the name of the employee who made the highest total single sale in 2014. Now, I bolded the highest total single sale. There's been several interpretations of this. There's one employee that has the highest total single sale for that year. So that's what we want to return in problem two. Okay. This data needs to include the filter tax and freight using order date for the, is that part of problem two? I don't remember. Oh, okay. So with as you're determining the employee with the highest total single sale, the manager also wants tax and freight and the order date for that year. So the CEO has also requested that you provide the winner's email address. So do whatever you can along with that employee. You want their email address. You want the amount of the highest sale, including tax and freight and the order date. Any questions about problem two?
I do.
Go ahead.
Just real quick on the previous slide. Yes. Just to confirm, I think you explained it, but I just want to make sure I have this right. Highest total single sale. So this is not for employee who had the most sale. Like we're trying to find out who had the highest amount of like highest single sale. Like someone might have had a
one item,
150 item, 150,000. I'm just throwing the numbers, but they might have been actually second from the bottom. So you're not looking for who had the most sales. You're looking for the single highest sale, correct?
That's correct.
Okay.
And it's worded that way on purpose. So,
Okay.
So you're providing yourself clarification. So highest total single sale.
Okay. I just don't want to select the person with the most sales. I'm totally off the topic then.
Yeah, and believe me, that has been argued quite often. So that's why I was trying to emphasize this is going to be a single sale, not total for the year. Yeah, I just gave you half the critical thinking part of it. All right. Okay, so you have two problems just dealing with aggregate functions. And yes, you are going to use aggregate functions for both problem one and problem two. So prepare yourself for that. The second half of the assignment for this week involves null values. For the null value assignment, you will have 3 exercises in which you will analyze data, develop queries, and return queries that return null values, then use case logic to resolve the data. Basically, I do not want to see null values in your results. That's the key here. All right, so the first problem for the null values, or problem 3 of the assignment, Joe Barry's manager indicated that Joe was taking paid time off this month. He wants to ensure that the system reflects this information. Okay, the hour spreadsheet, those of you that, I wanted to say this right off the top. I mean, it's go ahead and create a table just like you would, like I was asking you to do, to import the values from the spreadsheet. I'm not gonna write out an alternate assignment, but that spreadsheet just has hours for the month, so it has 4 weeks. You'll see it. I mean, it's pretty easy to create that table for this for this assignment. if you want me to write that out, let me know. But I do want you to evaluate that spreadsheet and just create your temp table or permanent table based on that spreadsheet. Everyone else, just import that. It's an Excel. Import that into AdventureWorks and go ahead and satisfy the assignment requirements, which are, so you want to add Joe Barry's hours together for the month and title that field monthly hours. So use the knowledge that you have learned, and you'll see that you'll have to do some magic in there to make sure everything totals correctly, because I'll just tell you, it's not going to be a simple sum. So use the knowledge you've learned about nulls to provide the solution for the manager. All right, so that's problem 3, or the first problem for your null values. Problem 4, human resources manager wants to classify employees who are absent during the entire month as inactive. So using a case statement, write a query that classifies employees as active or inactive. So, and a column title status with full name. And I do want you to concatenate. So use whatever you learned about concatenation to do first and last name in one column labeled full name. So in essence, you need to figure out where, I have to remember. Yeah, so you need to figure out where these data are housed in the database. And remember, the criteria for this assignment is that you want to classify employees who were absent during the entire month as inactive. Now, I tried to make this a little clearer. Once you look at the data, you will see that, well, I don't want to give you too many hints. You'll see that it's easy to classify an employee that's been missing the entire month as inactive, and then everyone else is active. Now this I will tell you, if you have questions about this assignment, please ask, because this assignment is very, you don't have a lot of information, but you have enough to satisfy the requirements. I would start off by figuring out where these data are, and then go from there. And then you have to understand what your case is going to look like. And so this has several steps, and it's not going to be as straightforward as you may think. I'll just say that. And the thing of it is, here's another kind of a warning. Once you've done problem 4, don't think that problem 5 is easy, or just changing the query to accommodate. It has a little caveat to it, and most students don't get it right away. So all I'm saying is be careful with problem 4, with problem 5 after completing problem 4. That being said, problem 5, all I want you to do is just use the same parameters, but rewrite the query to provide only, I should have bolded only, I just want only the list of inactive employees. So problem 4 is a list of active and inactive based on the criteria that inactive employees were missing or absent the entire month, and active employees were not. And then problem 5 is just a list of all inactive employees. Any questions about the assignment?
No, Professor.
Go ahead. Well, nope. Okay. All right. So we have some kind of analysis / evaluation for in-class participation. Basically, I'm going to give you a series of queries with nulls, and I want you to run them within the database environment, briefly explain the results and why they're being why they would be used. So I just want you, this is essentially, investigating the queries, analyzing why it's used and why it can be used or why it would never be used. And the queries are, you're using a coalesce. If you don't know about coalesce, it's a very good way to handle nulls. And I'm not going to read the queries. I want you to go ahead and read through them, run them, and then offer an explanation as to what it does, and then why would you use it. The first one is coalesce. The second one is null if, and the third one is null. So I'd like for you to work on those. You don't have to work on them in class. I'm going to stick around for a while. It's only 6:30. But that's basically all that I'm going to lecture. And those queries are all available in the QTI. So I do want you to run them. So I do want to see that the queries have been ran. So, take a screenshot of the results and all that, and then post that in a Word doc along with your explanation of each query. Okay?
Okay.
So that's our lecture for the evening. You can stick around if you like, or to work on these queries, or run them and evaluate them, and then or work on the homework. But you probably will come up with questions. Just let me know. But that's all I have for this evening. All right. No one's saying anything. Are you all just awestruck?
Trying to run those queries.
Yeah.
So hopefully y'all been able to access the queries? No problem there.
No.
Yeah.
Yeah.